Welcome. It is episode 2 of the SciManDan podcast. We're up and running. Catz and I had a great chat in the first episode. Hope you all checked that one out and enjoyed it. Today we've got a special guest with us today, but before we speak to them, we're going to bring in Catz again, my ever loyal co-host Catz. How you doing, matey?
I'm very good, and I'm really looking forward to this one. I'll not spoil the surprise of who it is, but I am very much looking forward to this one. So
good.
Well done on landing it.
Yeah, thank you very much. I have to say though, I'm not in a great mood because I went for a run today, and I got shouted at by a woman for the first time ever. Can you believe it?
What were you doing?
I've got my watch has got like a map on it, and so I'm following this map. I don't know where I am, like in the middle of nowhere, and the paths are sometimes quite close together. I took the wrong turn. It went down this woman's drive, which is like out in the country, so it's quite a big drive. And she started shouting at me, and I was like, I'm really sorry, but she was berating me, saying, "Oh, you're lucky the dogs aren't here," and so I just ran off. Bearing in mind this is 15 miles into like a long run, so I'm absolutely knackered. So yeah, that put me in a bit of a bad mood. So how's your week been anyway?
That's been alright, mate. I've been fine. I've not got myself in any bother this week. I've not been running down anyone's drive, or it was not a sign like private property or anything like that.
Was there a sign? No, there's no signs. No.
Yeah.
But if you go out on a run like that, you tend to find that a lot of the trails are like near people's houses and through farms and stuff. So it's just normal anyway. But I don't know. I was just a bit annoyed by it. But hey, anyway, I feel like I owe you a bit of an apology, Catz, because we've got this thing we mentioned last week, didn't we? You support Blackburn Rovers, and yeah. I've got this little habit where I find Catz live at any point on YouTube. So I find him live, and I'll set myself up in the chat, and I'll say, I've got a question for Catz, and the host normally finds me and says, "Oh, Dan's got a question," and it's normally some sort of loaded question regarding how poor Blackburn is, isn't it? I feel like I keep putting you off. I'm sorry about that, mate. I thought I had to get it out there.
It's all right, mate. I mean, it was all right until last week when I was
recording
the match to watch it afterwards, and you spoiled the result for me. That hurt more than anything else. But never mind. I can live with it. I've been a Blackburn fan for long enough.
I can stop doing it. It's just I don't go finding you. I don't go out and find you just off on the off chance.
It's our thing. I like it, mate. Yeah. It's our thing. You keep up with it.
One day
I'll just block you from the channel next time.
One day I'll ask you an actual question. One that's relevant to the debate you're in. Okay, right. So let's bring in our guest. So the guest this week, she definitely knows her way around a galaxy or two, that's for sure. She's an astrophysicist at Christchurch at the University of Oxford and runs a very successful YouTube channel named after her lovely self. It is, of course, Dr Becky. Welcome. How are you doing?
I'm good, thanks. Yeah, I'm still reeling from the fact that Catz is a Blackburn fan because I'm a Bolton fan.
Ooh.
And I feel like I shouldn't have brought that up in this
right.
because you're just going to rip me for it. But
Catz is going to drop out in a minute. Anyone who's not aware, anyone who's from America or anything, Bolton and Blackburn is a not the biggest rivalry, but it's a fair rivalry, I would say, wouldn't you? Is that a fair? Yeah.
It's known, definitely known. But my wife's a Bolton fan, so I get plenty of that. I've got a soft spot for Bolton for that. So.
Right.
I'm a Southampton fan, and the majority of my friends are Pompey fans, so I know the pain. Anyway, Becky, thank you very much for joining us. It's great to have you. So you are an astrophysicist at the University of Oxford. Tell us a little bit about your position.
Yeah, so I'm what's called a postdoc at Oxford. So essentially that means I have done my doctorate degree, my PhD, and I'm now doing research. It means I'm not quite yet a professor. So there's a lot of people online that are like, "Oh, professor, can I ask you a question?" And I'm like, stop giving me a promotion. I'm not a professor yet. I don't have like a permanent job. I'm just hired by the university for a couple of years to do some research. The research that I want to do, that I've said to them, you've got this pot of money that you can pay researchers with. This is the stuff I want to do. Do you want to hire me? And they said yes, which was great.
Nice. Yeah.
And I spend my days basically thinking about the universe, essentially. The role of a scientist is to answer questions we don't know the answer to. And I collect data with telescopes, and I analyze that data, and then I write up my findings in a journal article that's published to the world. And that's sort of the nice cycle of things. I don't really have a general day-to-day, but it's definitely a cycle of going to telescopes, coming back, analyzing data, writing a paper, going back to telescopes. It's really fun.
Well, I saw your video on the a day in the life of an astrophysicist and on your YouTube channel, and I have to say that is a brilliant channel. I watch it quite a lot. The first time I ever heard of you was Fraser Kane asked me to do a Q&A for his channel. And he, as an example video, he sent me your Q&A that you did for him.
Oh,
so
nice.
as a thing that he was looking for, and that's when I first kind of discovered you. And funny enough, we'll talk about it in a bit, but you did a video this week which is quite relevant to what Catz and I do, but we'll talk about it in a bit. But
yeah,
how do you find YouTube, your channel?
Yeah, I mean, I love it. Like, I love that people are as keen about space and astronomy as I am. Like, I feel like I've found my people that would just want to chat about it all the time.
Yeah.
Which is great. And the fact that many people want to hear from, a scientist that's doing the research themselves, that's always what I want it to be for people. Like, the tagline of the channel is your friendly neighborhood astrophysicist. It's all the questions you never able to Google, you can ask me, kind of thing. And if I can get a chance to get to it, I will. And I just really enjoy it. I just love having that connection with people. And I think that's what's so great about YouTube, is that it does put you in touch with people that you would never have found otherwise. I think that's what's so great.
Completely agree. I mean, I would never have found this good man here, Catz, if it wasn't for YouTube. Catz is tell us a bit about your qualifications again, Catz. What's your background?
Well, my background was my degree, my master's degree, were in the biological sciences, but I'm a science teacher for profession. I've been for 20 years, and when I landed in my first teaching role, it was as a physics teacher. So I spent the last 20 years teaching physics, up to A level, etc. And I love it. I love when we get around to the astronomy side and astrophysics side of the A level stuff. And obviously, you've probably forgotten more in the past 5 minutes than I've ever known about it. I'm well aware of that, but I'm fascinated. The kids love it. It really grabs the attention, doesn't it?
Yeah, and I wish the curriculum didn't wait till A level, till 17, 18. I wish that we did it more at 11 and 12, because I think that's the era when kids are most curious.
I was just going to say that.
Really get them with space stuff, because that,
Absolutely.
It raises more questions than it answers, right? Sometimes. So.
Yeah, I think from memory, Catz, unless you're doing a specific GCSE in physics, you don't really do much on space, do you?
The Key Stage 3 curriculum, different schools vary, you'll learn about the planets, etc. But you're right, certainly with the main AQA specification, unless you're doing triple science, physics as a standalone, you don't
hardly do anything.
It's a shame, real shame.
Yeah,
I think it's because exam boards have decided it's just too hard for kids of that age, and I'm like, it's not fair. Let kids make their own decision on what's too hard and what's not too hard. I think it's interesting enough to grab them that they'll actually want to put the effort in to understand it.
Absolutely. So. I've tutored a couple of kids who went to private schools and they did GCSEs in astronomy, and they were the kids that I tutored were fantastic at it. They really got a good grasp of it, and I reckon you just got to give those kids a chance who might want to learn in GCSE to actually learn it. Because from what I can remember, it's a bit about redshift, a bit about the start of the universe. I don't know if there's anything on planets, is there?
Well, so we're talking about the astronomy GCSE.
No, just the normal space stuff in double science.
Steady state versus Big Bang Theory.
Yeah.
CMB, redshift. There's no difficult maths. I think they mentioned Hubble's constant, but not how you calculate it or anything like that. The maths is dumbed down for the physics.
Yeah.
But still the topics, which is good. I always like to class astronomy as a gateway science.
Yes.
If you can hook the kids with space early on, they'll all become engineers or whatever it is later. But at least you hook them with space first.
Yeah. Everyone loves space. Everyone loves space. So, Becky, you focus on low redshift galaxy evolution. Now, for the purpose of the audience, I think I'm correct in saying here that would be galaxies that are not receding too fast. Is that right?
Yeah, and are therefore a lot closer to us.
Okay, cool. So could you explain a bit why you decided to focus on those particular galaxies?
Yeah, sure. It's funny that you say that, you read it out you study low redshift galaxy evolution studies. That's really how I'd introduce myself, like a fellow astrophysicist. You'll find that we do this, we introduce ourselves with what redshift are you? Are you low redshift? Are you nearby stuff? Or are you high redshift? like far away stuff.
Yeah.
What wavelength are you? Are you optical? Are you infrared? Are you X-ray? Are you gamma ray? Like, and then like, what object do you study? So I'm like low redshift, optical galaxies. Right. Like nearby visible light galaxies. And I think the main reason for that is just, I like to be able to really see the shapes of galaxies that I'm studying. You know, I don't want some fuzz blobs that are, you know, billions of light years away that I can't really see the shape of and get a grasp of. And, you know, those beautiful images that you get from the Hubble Space Telescope, that's what really drew me into science as a kid and space as a kid as well. So when I got to the level where I was deciding, okay, what are you going to spend not just the next 4 years of your life doing during a PhD, but probably the next sort of your career's worth of life doing, it was a bit of a no-brainer for me. I just wanted to be able to understand galaxies better, what shapes they were. You know, you see the shapes of galaxies, you see these beautiful spiral shapes, you see these weird blob-ish sort of very round shapes, and then you see even the weird and wonderful things that are either torn apart, or there's even the penguin galaxy. It looks like a penguin. Like, just do yourself a favor and go Google penguin galaxy. It's the best thing you'll see all day. And like, just trying to understand why galaxies are the shape they are, how they've evolved to be that way, how they interact with the supermassive black holes at the center of them as well, and whether the shape governs that at all. That's just something that I was so drawn in by, more so than cosmology, which I know draws in a lot of people, the idea of the Big Bang and understanding how the universe started. Sure. Cosmology's data is really boring. Like, it just looks so boring. And I was like, nah, I want to work with the data that, you know, when I'm analyzing an image on my computer, if someone walks by, they want to stop and go like, whoa, what's that? That looks amazing, you know? And that's really why I'm there, because the shape is so interesting, because it essentially encodes the history of a galaxy. So if something is a beautiful spiral shape now, like in the universe, very close by, it means that it's pretty much been left alone its entire life. It's been able to stay that beautiful, pristine spiral shape. But if it's instead like a circular blob now, then we know that in its history, it's probably merged with another galaxy, and that's ruined the spiral shape and it's destroyed it. And so you can pick out what kind of galaxies you want to study, like what kind of history they've had, just by picking out their shape. And that fascinates me. I think it's really cool. So
you gave a little insight into our future there, didn't you? Is that what we're going to end up at as a blob?
Yeah. So the Milky Way is going to merge with Andromeda in the next 4 or 5 billion years or something. And in that process, essentially all that beautiful spiral structure in both the Milky Way and Andromeda will be torn apart by the gravitational interaction. So basically everything, all the angular momentum and energy will get redistributed. And so instead of being on really nice sort of circular-ish orbits around the center of the galaxy in that flat disk, we're essentially going to end up on what I like to describe as like a beehive, right? Everything will still be orbiting the center, but it'll be doing so chaotically, you know, in all different planes and directions, that it will be like sort of like a beehive of stars is what we're going to end up with, which is a big blob of stars.
Would that be damaging? Like, because my daughter was asking me this the other day. She'd seen on TV, you know, Andromeda and the Milky Way, and she said, "Dad, if we were alive when that happened, you know," and I know, you know, obviously it takes a very long time, what would it be like? And I didn't have a clue what to say. Like, would it be something you'd notice, or like if you were on a planet, would you feel something happening different, or you know, what would it actually look like?
I don't think you'd ever feel something on a planet happening different. You'd be able to see it in the sky for definite. Andromeda would just be getting bigger and bigger and bigger all the time. And the night sky would just get brighter and brighter as these stars got closer to us, until eventually, you know, the number of stars in the sky would just far outnumber whatever we see at the minute. In terms of what would happen to the planet, though, I mean, it depends what happens to the sun, basically. Whether the sun will still be alive in 5 billion years or so is one question. Let's assume it is. The one thing that always surprises people is that no two stars collide in a galaxy merger or collision, just because space is just so big. The probability is just so small, because literally the cross section of how much of the space in a galaxy is star and not empty space is just massive, right? If you think about an atom, right, when we talk about the nucleus is such a tiny amount in the actual space of an atom. It's like 99% of an atom's empty space. Similar thing with a galaxy. So no two stars will collide. It's just where we'll get flung by the gravitational forces. So you can see in these either simulations or pictures of mergers going on, you see these big like streams of stars that have been pulled out and off the galaxy. We could end up in one of those, like way out, or we could end up being flung towards the center. in this redistribution of energy. We could sort of like sink to where it's getting heaviest in the center. And if that happens, you know, like way out in intergalactic space, we're going to be not very well protected from sort of cosmic rays and all these very dangerous things in terms of life. But then as you get closer to the center, you've then probably got a very active black hole after a merger as well, because it's being fed. So that's going to be throwing off huge amounts of radiation too. So both prospects don't look great. Let's be honest.
Yeah. So you can tell your daughter, Catz, that it's not good news, mate.
Yeah. Yeah. Oh, thanks for that. Cool.
It's interesting you mentioned the shape of galaxies. Well, during my studies, I learned quite extensively at the beginning about Hubble's fork diagram, which of course is a general guide on how galaxies evolve. Can you see that changing in the future as you and others continue this sort of research, or is that something that is pretty much set in stone now?
I think it will always be used and always be taught, but it has already changed. In fact, work that I did last year with the Galaxies U team has revised it slightly. So it has been revised over the past sort of in the 20th century. It was revised by de Vogler. He came up with an even more intricate way of classifying things, much more detailed. So Hubble just essentially had, you know, how round is a galaxy? Yeah. And then if it's a spiral shape, does it have a bar, first of all? And this is where the fork comes from. The bar galaxies go down one end and the normal spiral galaxies go down the other fork. And then along the fork, it's basically how tightly wound are your spiral arms? Are they very loose or are they very tight? And then also Hubble added into that, okay, in a spiral galaxy, you have this very central bulge of stars as well, which is sort of like a mini version of the very round elliptical blob. So if you have a merger with something that's a lot smaller than you, essentially you just form a little bulge in the center, but keep your spiral arms on the outside. And so Hubble said, okay, let's classify them as the things with the really big bulge with very tightly wound arms on one side, and then the things with very tiny bulges with very loosely wound arms. I think because back then they thought that spiral galaxies were sort of winding in on themselves and slowly winding up over time, which has been proved false now. But that's how we classify them. And that's sort of been the given for many decades, because if you think about back in Hubble's day, he was classifying like a handful of galaxies is what he was working with, maybe 100 if he was lucky. But now we have surveys of the sky that have observed 1 million galaxies. The question is how you then classify them, because computers aren't great at this yet. They're still lagging behind, like humans actually doing the work. They're getting a lot better, but they're still lagging behind. So a decade ago, we actually had a big project called Galaxy Zoo, which is still running. It's a website where you get the public to actually classify real scientific data. In this case, it was images of galaxies that had basically been sat on a computer archive for years because there wasn't enough astronomers to actually eyeball them all and say that's a spiral or that's a blob.
Oh, is that a bit like where you're looking for exoplanets? That website?
Yeah, it's the exact same site. Yeah,
awesome.
So Galaxy Zoo started it, and then all these astronomers turned around and went, oh my gosh, I have the same problem. I took far too much data. And so the Exoplanets project was also spawned off that. It's now this whole collection of projects called the Zooniverse, everything from space to historical research to penguins in Antarctica. There's just all sorts on there. It's great. Kids love it, especially. And they're actually contributing to science, which is great. But off the back of this, it meant that we could classify with Galaxy Zoo all the galaxies and get classifications for how tightly wound their spiral arms were and how big their blobs were in the center. And so last year, back in 2019, myself, along with the Galaxy Zoo team, published a paper that actually showed that correlation that Hubble just assumed actually doesn't exist. And the majority of galaxies actually have very small bulges, but very tightly wound arms, which is sort of the opposite of what Hubble said.
Wow.
And that's where the majority of them lie. And so we're already sort of revising it and saying, actually, when you look at the population as a whole, that's what you find. And that kind of data just wasn't available to Hubble. It's not that he was wrong. It's just that he didn't have the full picture yet.
Of course. So obsolete soon then? Is that...
I don't think it'll be obviously, like I said, I think it's a great
it's a great starting tool, isn't it? Yeah.
Exactly. Yeah.
Cool. So how much do we really know about other galaxies? I mean, we know loads about our own, but how much do we know, or more importantly, how much more is there to learn about other galaxies?
I always say that. I think there's more that we don't know than we do know. And you said we know a lot about our own. There's still a lot we don't know about our own either. You know, we know more maybe, but there's so much we don't know. We don't know how galaxies end up stop forming stars properly and what like the dominant way they do that. We know they do stop forming stars because there's a load of like what we call red and dead galaxies out there, as opposed to sort of the very blue star forming spirals that we see. And we don't know if the black hole plays a big enough role in that. Like theoretical simulations have been saying for ages that the supermassive black hole in the center has to shut down star formation. Otherwise, all our models break down. But we've really not observed that happening yet. I'm trying to find observational evidence of that. That's what I'm doing as part of my job. We still don't know, how many different types of stars all form in galaxies. We don't know when they form the majority of their stars. We don't know how even spiral arms form. We have two different mechanisms that we can simulate them forming by, but we don't know which one actually happens in the real universe. And there's still big arguments about that. There's so many things. It's such an active area of research. And, it might not be the most glamorous anymore because you've got exoplanets, finding water on exoplanets and taking everyone's attention away. You've got cosmology having all of their crisis where they, are finding things that don't agree all the time. And I'm like, but galaxies is where it's at. We got the pretty pictures. Like, come to us, So I love it. I think it's great.
If there's things that you were saying that we don't know the answer to, okay, if you could wake up tomorrow and have the answer to one of the questions that you were trying to ask in your job, like what would that question be that you'd want the answer to?
That's a big question. I almost wouldn't want to wake up tomorrow and it just be answered because it's like, the lead up to Christmas is almost sometimes more fun than actual Christmas. Like it's that kind of thing. Like the doing and finding out the answer is the exciting part. If someone just told me, it almost wouldn't be as fun. But I guess I actually would probably pick something that's not my area of research. I would probably pick, like what is dark matter? That would be great if we could just know that already. Particle physicists, we've waited long enough. Yeah. We've so much astronomical evidence that it exists. So many different areas, so many different fields of research. It has to be there. We just need to know what it actually is made of in terms of a particle. My research, I'd probably say that this answer of, are supermassive black holes actually affecting galaxies in terms of are they putting energy back into a galaxy that stops a galaxy from forming stars? Like I would love to know if that's actually happening, because if it isn't happening, then our best model of the universe needs revising because without that process, it doesn't work.
For me, I've always loved learning about galaxies, and I know, as you say, cosmology is a bit of a dodgy one at the moment in terms of how they're coming up with things, and I don't know what it's like for you, Catz, but when you teach A-level physics, how interested do you find they are about the galaxy stuff, the kids?
I honestly find that when I'm taking an A-level physics class, the first thing they ask is, because they've all checked the specification before they've opted for the course, the very first thing they ask is, when are we doing the space stuff? When are we doing space stuff? There's very, very few. Nobody ever says, when are we going to learn about Young's modulus? Nobody ever asks that. Right? It doesn't have,
when are we doing the double slit experiment?
That's it. Yeah, when do we do that? No,
when are we doing pendulums?
When are we doing the space stuff?
Yeah.
Brilliant. Becky, you know what I do. You know what my thing. Catz does the same. We're
an honourable job, guys. Seriously.
Thank you very much.
One conspiracy theorist at a time.
Yeah, exactly. Yeah. But we want to know how much experience you've had with conspiracies concerning space. For example, did you know that some people think space doesn't exist at all?
Yeah, I've heard about this. And it's essentially like flat earthers got tired of us actually using logic against them, so they came up with the most illogical argument they possibly could, basically.
They won't have us. They won't have them being a flat disk in space. There's just no space. That's how they solve that one. It's a crazy world. Have you had any other experience of anything else other than anti-space?
I remember the first conspiracy theory that I ever heard about or came across, was I was in year 9 and it was my English teacher in year 9. talked about how she challenged something that I'd said about the moon landing. And she was like, how do you even know that we landed on the moon? And I was like, because we did. And then she was like, no, there's this whole conspiracy that we didn't. And that was the first time I'd ever heard about it. And I remember going away and reading it and almost feeling myself sucked in and sort of like this 14-year-old that was impressionable. And then just going, no.
Yeah.
And just realizing how ridiculous they all sounded, describing it and coming up with these little things and realizing that it all came from a misunderstanding of the physics, essentially, and I think
Absolutely.
that's the majority of conspiracy theories stem from, right? It's that I don't understand it, therefore something else must be going on.
Exactly.
Not that there are things out there that you don't understand. And I almost think that's the first thing that you realize as a scientist, is that there are so many things that we don't understand. And that's almost a good thing, because now we can figure them out and we can learn stuff. And I wonder whether it stems from and no shade here to science teachers at all, Catz, but I wonder if it stems from how science is taught at school. It's taught here are the facts and these are the facts that you should learn, rather than here's how we figured this out, because this hasn't always been known. You almost learn it as if this is humans for eternity have been learning this by rote because it's always been known. And it's almost I think the fun bit is actually figuring out how, the process of figuring it out, and then teaching people that process of how we figured it out and giving them an understanding of how long science takes as well. And I think that's really been highlighted during the pandemic as well, that people we should know this. And it's no, science takes time. I can't believe we have already got a vaccine in the space of 9 months.
Crazy,
maybe.
Yeah,
that's ridiculous to me. But people are going, come on, where is it? And that science could take 10 years, 50 years to come to any form of conclusion. And I think that's almost the instant gratification monkey that's inside of everyone, gets
I often
gratification from conspiracy theories.
Yeah. I often cite Richard Feynman, who said that he was at the end of a 400-year journey. So it's very difficult to just say, this is what it is. I need to go build before I can tell you anything. It's interesting you said about the moon landing one, because 21% of British people think that it was faked. Does that surprise you then? Now after your story from the English, 21%.
Honestly, that 21%.
1 in 5.
I didn't think it was that high. I would have probably guessed it was that high in the States, just from mistrust of government.
Oh, I'd say it was higher than that in the States. I'd say it was 40-ish%. I mean,
that's crazy.
You say
yeah. I mean, in the UK, I bet half of it stems from just sort of a dislike of Americans, probably.
Probably.
But yeah, I just don't get it. I mean, the first thing is who do you think would have been benefited the most from telling people that they didn't land on the moon? Russia and China, do you think? And yet, no, they're all they know that that America landed on the moon. So we know that humanity landed on the moon. It's not. Yeah, it baffles my mind that people can fall down that thing. And I think again, it's from a misunderstanding of what you need to know to get to the moon. You just need Newton's gravity even to get to the moon, and you need something that can basically just gives you thrust. You need thrust and Newton's gravity, and that's it. And you could do that with 3 astronauts that were incredibly brave, and the tiniest of computer, even if it was most people were just doing the calculations by hand. You could get to the moon, and that's all you need, just a little bit of guts and courage to do it, right? And people are so in disbelief that could be done with so little tech. I think that's where almost the disbelief stems from. Yeah, and
I think Cat's can agree with me on this one. One of the things that we find so abhorrent about it all is the fact that they will say that things are fake. For example, the space shuttle that exploded, they will say that the astronauts are still alive because they found people that have the same names and look a little bit like them. All easily debunkable, but it's not. It's not nice in any way, shape or form. Yeah, exactly.
The other thing that gets me is that people are more willing to believe that they had the technology to fake it than they did to actually send people to the moon. And it was actually easier in the 1960s to send people to the moon than to try and fake it. That's the tech they had, and that's the tech they didn't have.
Yeah, so. Absolutely right. There's a really good video, I think, from a photographer, I can't remember the name of the channel, who said about how difficult it would have been back then to fake exactly what went on the moon. So I mean, Catz and I do a Flat Earthers Weekly on our channel. What do you think of the Flat Earth gang?
I'm almost sad and disappointed in them. That makes me sound like a parent, like I'm disappointed, doesn't it? But like, you must have seen the Netflix documentary.
Yes,
on
yes,
Flat Earthers,
we've seen that.
And I remember watching that and being like, oh, come on, you're so nearly there. You can see them almost following the scientific process in designing experiments and coming up with a hypothesis to test. It's just that moment of when the evidence shows them something that doesn't align with their worldview and with their emotions that are tied to this hypothesis, that they don't change, their worldview. And it's that thing that is the missing bit, right? In science, you have to be almost detached, which is difficult because when you do spend your life, studying something specific, but you have to follow the scientific process. And that point is always looking at what the evidence shows you. And if the evidence is against your hypothesis, you have to redefine your hypothesis. That's the basics of science. It's how science moves forward. And you can see them registering the evidence, but not doing that last step. And I just kind of think, well, what happened that you became so attached to this idea that you're not willing to do that? And like, what could you have done in science otherwise? You know what I mean? If you have this mind that can design these crazy experiments to test this, what else could you have done? That's why I'm disappointed in it.
Yeah. Catz always says that they do the experiments and then they come up with their own physics laws to explain them, don't they? What's the one?
The laws that they come up with are unbelievable. Some of the things that my favourite is what they'll film a boat going over the horizon.
That's it,
and then invent something called compression or the ether band, which is some optical effect that nobody in the universe understands, but it's what causes boats to disappear bottom up as they go over the horizon. And I wish I was joking with that. I wish I was joking, but I'm not. It's amazing.
Yeah. What gets me though is that, like, I know it sort of stems from this, like, when I look at the Earth, it looks flat, and it's like I only believe what my eyes see, kind of thing.
Yeah.
And it's like, that's what makes them question it in the first place. But I'm like, why don't they question, like, the human body is made of molecules and atoms, like what, that you can't see those, all you see is sort of a solid object. So I don't understand why it's specifically flat Earth and not like any other thing that you can't see. The fact that water is made of H2O.
Yeah. Well, hey,
do you know what I mean? It's like, where does this come from?
You say that, but there is a conspiracy. One of the first things that Catz tackled was that water was not made of H2O. What is it they said?
God. I can't believe that.
It was water was an element.
An element.
And
that's
it.
it.
Even given a name, Aquium.
That's it.
Aquium. Where does that even stem from?
Oh dear. So, there's a conspiracy in everything. There really is.
No, the funny thing is that, like, I remember a couple of years back when I used to work at the University of Nottingham with Mike Merrifield and people like that from the 60 Symbols, people might know him from. I remember we had a great chat one lunchtime, and he was saying, I've been called up by a BBC radio station this morning asking me to go on, because they have to be impartial. They didn't just get him to comment on whatever story it was. They also got a flat earther on. And he basically just was like, I had to spend half an hour just replying to this BBC producer. I think it was BBC. Maybe I'm throwing them under the bus here, but this BBC producer saying, like, I will not legitimize this as a debate. You do not have to be impartial to something that has been known for 4,000 years. Like, and it's just crazy that you get to that level and you even have to explain it to someone who should know better, but that's the point that you're in. And you constantly get this sort of pushback from the flat earther community, if they want to call themselves, about being like, oh, scientists won't debate with us. And it's because it's just not a debate. Why would we waste our time? It'd be like, as having a debate about whether the sun will rise. Like, what's the point? It's going to rise.
Yeah.
It's a waste of time.
Well, I mean, these guys do, some of the debunkers do debates with the flat earthers, and it's always an absolute annihilation, and they can never accept a loss, can they, Catz? When they get beaten in these debates.
They're incredible to watch.
And sometimes they think they've won, don't they? Sometimes they genuinely think they've won the debate when it's clear that they were trounced.
Well, I mean, you can present to them. My favourite thing, at the minute is the Eötvös effect. You can present to them, real measurable things to show us, rotation, etc. And it doesn't matter what you tell them, because you've told them over a computer screen and maybe you've shown them a diagram. All their take-home message from that is, you've just shown me a diagram.
Yeah.
So therefore, that's not proof.
Means
it's only
nothing.
a diagram.
Yeah.
It's only words over a screen. You're not showing me anything and thinking, why are we having the conversation?
I have the best one actually. I remember it was right as I started my PhD, and I was like, I'm gonna maybe engage one and see what happens. Error. But I remember them asking, like, they were like, I want to see a video of your Earth that's supposedly round, like rotating in space. And I was like, okay, here's a time lapse from the Discover satellite, which is in one of the Lagrangian points between the sun and Earth. It's constantly pointing at Earth, and there you can see it's rotating. He's like, I don't want a time lapse, I want a movie. And I'm like, well, they're kind of the same thing.
Yeah.
And he was like, no, a time lapse is just images played in quick succession. And I was like, what do you think a movie?
I don't think it would have mattered. They would have cried fake. They would have cried fake. Whatever you show them, they'll cry fake.
Yeah.
CGI fake. There's nothing you can show them.
Yeah.
Short of,
Exactly.
I would even suggest that if you took them up into space, that they would argue that the curve in their helmet is causing the Earth to be curved. It wouldn't surprise me at all. Right. Okay. We're gonna play our little game. We're gonna play our game called Guess the Conspiracy.
I'm excited.
Hang on. I've got a jingle.
It's so ethereal. It's
So,
beautiful.
yeah, it's lovely, isn't it? So this is the part of the show where Catz and I try and trick our guest. So what's going to happen is I'm going to give Dr. Becky 3 conspiracies. 1 is real and 2 are completely fabricated by Catz and I. So the idea is that Catz and I believe that we're so entrenched in the conspiracy world that we can come up with conspiracies that could potentially be real. So...
I'm excited for this.
Okay, so we'll give you 3 and then we'll let you think about it and you can talk through them.
I mean, the 2 aren't real now, but watch like 2 cults.
Oh, I know. I did think about this.
You've
I thought about this when I was planning it. I was like, someone's going to grab hold of these. Anyway, here we go. So number 1, the speed of light is not a universal constant, as humans are the only beings to use numbers. That's the first conspiracy. The second one. Absorption lines in spectra are evidence that aliens are trying to communicate with us using some sort of code that we haven't figured out yet.
I hope that one's real.
And the third one, the second law of thermodynamics dictates that a vacuum cannot be next to an atmosphere.
Right.
So there's your 3. What do you think? What's first impressions?
Okay. So the first one, I know there is a weird conspiracy about the fact that the speed of light, it has the same numbers in it as the coordinates for like the pyramids of
there is a conspiracy
Egypt
on
or
that.
something like that.
Something
and
like
it's
that,
just like, it's a coincidence. Our numbers are a construct. Like, no. So I can imagine that could be real because it could stem from something like that. But the fact that, like, what did you say it was? Because numbers don't exist?
Because human beings are the only beings to use numbers. So it's not a universal constant because no one else out there will understand it because we are the only ones that use numbers.
Yeah, but even though we don't use... No, I'm not even going to try. I'm not even going to down that route. Number 2, I really want to exist. Like, I would... Because I use absorption spectra all the time, so I would love it if there was some alien code in there that I've just been missing for the past 10 years or so. The fact that it's always at the same wavelengths, like, why am I trying to logic this? It's a conspiracy theory. It would never make sense in the first place. What was the third one? The vacuum.
The third one is that the second law of thermodynamics dictates that there cannot be a vacuum next to an atmosphere.
But you just have a gradient and...
True.
Oh,
True.
that definitely sounds like something that someone's completely misunderstood the physics for.
So are you going with that one?
I'm tempted to... I want number 2 to exist. I want number 2 to be real, but I don't think it's number 2. 1, I'm like, that could be... but I think it's a bit tenuous. So I'm going to go with number 3 because that sounds like something that stemmed from somebody's misunderstanding and has become a conspiracy, which is basically my definition of a science conspiracy.
Catz, we need to do better, mate. Well done. Very well done. Yeah, so that is actually one of the key arguments from a flat earther who claims that space isn't real because of the fact that there's a second law of thermodynamics. And obviously they have the notion that gravity isn't real, so therefore there can't be a
you can't have a gradient in the
So,
atmosphere.
so it's a tricky one, that one. But yeah, so Catz and I created the other two. So well done. It's 1-0 to the get. We need to do better, buddy, because there's some high caliber guests coming on that we're gonna have to go on.
No, so we'll put Paul through, but I think getting that right, that Dr. Becky was talking about not quite being a professor yet, but I think we should award her
absolutely
an honorary professorship.
Yeah.
Puzzle we gave her.
Yeah.
I think that's it. Go back to work tomorrow and just tell them.
Yeah.
Got it.
I guessed the conspiracy on the SciManDan podcast. I am now an honorary professor. That's what you got to say. Anyway, thank you very much, Dr. Becky. It's been an absolute pleasure having you on. I hope
really
you
fun.
enjoyed
What
it.
a great way to end a science day, just with a fun chat.
Yeah, it's great, isn't it? Me and Catz had a great chat last week. So yeah, that hopefully everyone's obviously checked that one out already. So we are back next week. Our guest next week is a certain Mr. Jerry Coyne. Catz is a big fan of him, and as am I. So we need to get our evolution conspiracies, Catz. We need to get them.
Oh, got plenty of those ready,
Good,
mate.
Good. Yeah. Okay, but that's it. We're done. So thank you very much, Catz. Thank you very much, Dr. Becky, and we'll see you all soon. Goodbye.